All right, so let's do some review for the quiz. That'll come up on the chemical equation and identifying. So let's go over the basics. All right, so subscripts are outside the brackets. So this is the subscript here. Get my pen going here. So this is a subscript here, and it accounts for these brackets. So this is 2 times 3. So this means there's 6 oxygen atoms in here. Get my pen a little bit bigger here. All right. And so when you don't have a subscript, it's like a 1 in there. Okay. So this will be 2 times 1, 2 nitrogen atoms. All right. And the magnesium this does not count for the magnesium. So there's just 1. So the total of 8, 9 atoms. All right. So that's how they figured that out. All right, so identify the number of atoms in this lithium 2. So this is subscript goes with this lithium. Remember that lithium, capital L and little I means there's 1 element here. That's just 1, not 2. If that was a capital I, that would make a difference. So there are 2 lithium here, right? 1 carbon, so it's a subscript of 1, but we don't write it, and 3 oxygen. Aluminum, the subscript makes this 2. Okay, so the nitrogen at 3 times 1 gives it 3, and 3 times 3 gives it 9. All right, so coefficients are the large number in front. So here this 2 talks about, so if I were to draw NaF in a circles here, so here's an Na, and I'm going to put an X for the Na, and a blank one for the F. So if this was the molecule and those were the atoms, the Na would be the X, and then the clear one would be the F. So 2 of those would look like this. I'd have another one, right? I'd have another one. So that means there are 2 molecules, and if we count the atoms, there are 2 Nas and 2 Fs. So here, we got 2 carbons, and 2 times 2 is 4 oxygens. Right? Water, this whole molecule, so H2O. So this is 3 times 2 is 6 hydrogens, and 3 times 1 is 3 oxygens. All right, so this is how we got that. All right, not going to go into this anymore. I'm just kind of doing a review. All right. Okay, so let's go on to the chemical equations. So chemical equations, we have the reactants. They're on the left side. They react. They combine to make the product. So it's like you have parts. Okay, so product is always on the right-hand side. This is the yield symbol, means to produce. All right, these two. So this is a reaction of hydrogen and oxygen that gives us water. All right, so we're going to skip this part here, skip this part here. So balancing chemical equations. First of all, we cannot change the subscripts. All right. The reason we balance these is because we're using the law of conservation of mass, okay, that says the mass of the products must be equal to the mass of the reactants, and that is nothing can be created or destroyed when in a chemical reaction. We just rearrange things. So bonds are broken and bonds are made. So phosphorus, 4 phosphorus and 2 oxygens give us, we should have 4 phosphorus and 2 oxygens. So we cannot change these. So don't try to change these at all. Okay. Be easier, but that's a totally different element or totally different compound. Okay, so let's take a look here. We've got on the first part here, we have phosphorus, we have 4, and we have 2 oxygens. So I'm counting the subscript here. Phosphorus, we have 2 here and 3 here, 3 oxygens. So we notice that we have 4 phosphorus, so that we're going to take care of the phosphorus first. So let's see what happens if I multiply and if I make a 2 here. Okay, so now I have 4 phosphorus, so I can cross this out, and I have 4. And I have 6 oxygen. 2 times 3 is 6. So I've got this is fine. So I have to put a coefficient in front of this. So I'm going to put a 3. So what I try, again, there is no easy, I shouldn't say easy way, but there is no trick to this. You have to just kind of try them out. And again, a lot of times you have to cross things out, start all over again. I've done these a lot. So, but I make mistakes as well. All right. So here we go. These are the balanced equations here. Okay, so let's look at the coefficients. And again, it may be balanced. We don't know until we start counting. So we have 2 nitrogens on this side and 2 hydrogens on this side. So assume that there's a 1 in front of these. On this side, we have 1 nitrogen and 3 hydrogens. So I always go to the side. My rule is I go to the side where there's less. So nitrogen's less. So let's put a 2 here. Now I have 2 nitrogens, so that's great. And I've upped the hydrogen by twice as many, so I make 6. So now these are fine. Now can I make this turn into 6? Sure. I'll just multiply this by 3. Now the nice thing is that if you count the atoms up, you'll know you have the right answer. I'm going to just put a 1 in there so you don't get mistaked. Think it's a 0. So 2, 6. So I know that's perfect unless I counted wrong. All right. Again, I'm not going to show these because these are just something that show you the atoms. So like here's the 1s and a pair of oxygens and then 1 molecule. It's easier to do if you have, these are drag and drop, so, but not easy on a slideshow. All right, so let's go back over here. All right, so let's do the coefficients here. So again, I have, I'm going to make a count on my one on this side, the reactant side. I have 1 aluminum. I have 1 hydrogen and 1 chlorine. On this side, I have 2 hydrogens. I've got 1 Al, and Cl's I've got 3. Okay, so um, my suggestion here is that we go ahead and try, um, again, trial and error on this particular one. Um, the aluminums are fine, the chlorines aren't, but you'll notice that this one is a 1. Okay, so I could try this. I'm going to try to make this a 3, but because hydrogen is in a group of 2, that's where I'm going to have a problem because I'm going to make this 3 and I already have 2. So what we can try to do here, we can try some trial and error. I'm going to double this, and I did that so that I get an easier. Chlorine is 6. So I can do that. I can make this a 6 easier. I can make that 6 right here. Again, this is the tough one. I have to make a decision. And because I have numbers that are odd and even, I want to make them even. So I did 2 times 3 is 6. I got 6 over here. I can make this a 2. Right? And I can make this a 3. So now I've got 6 hydrogens, 2 aluminums, 6 chlorines. So this is probably the toughest one because, again, there's even numbers and odd numbers. Okay, so let's try this one. So Na, I've got 1. Br, I have 2. So, and a F, I have 2. So let's do this. Let's start with the Br, and make this a 2. See how that works. Now I've got 2 NAs and 2 BRs. So now I've got to come over here and make this an Na2. All right, now I've got this is the same as this. The BRs are the same as BRs. But now I've got 2 Fs. So that works out okay. So I can put a 1 here. So I got 2 Fs, 2 NAs, 2 BRs. Okay, and again, like I said, you could start other places and then just kind of fill in. Sometimes it works, sometimes it doesn't. Let's try this one. So aluminum, iron, and okay, so here we have a 3. And this might be okay to, let's try this. Because aluminum is, we have 2. Let's try aluminum. We'll put this as a 2, see how this works. 2. Okay, and then make this a 1. All right, so this has 3. Now notice that this is odd as well. So I'm not worried about this. So I'm going to just make this a 3. So now I can make this a 3. Okay, and I basically going to check. So I've got 2 ALs. Right, I've got 3 FEs, 3 oxygens. I've got Al is equal to 2. O is equal to 3. Fe is 3. Okay, so I balance those. And again, it takes a lot of practice, just doing over and over again. Okay, so we're going to stop right there.